3, Algebra 2 is all about using sampling. So a lot of this is talking about taking surveys and the kind of information that we get from these surveys. And so mainly, what we're working with here today is definitions of different types of sampling when it's used. So there's not a lot of math actually involved today. So I'm going to do a lot more talking than actually writing on the board. First thing we want to talk about is what a population is. A population is a group of individuals about which information is desired. So, if I want to know something about the boys at Milan C2, there's a population of boys, there's a population of girls, there's a population of freshmen, sophomores, juniors, seniors, right? There's a population of football players, softball players, baseball players, track runners, so on and so forth, right? Those are different populations by which I could desire information. A sample is a part of a population, not the whole thing. When the sample is representative of the population studied, the results from analyzing the same can be extended to the entire population. So if I want to know something about the entire population, but I don't want to ask every single student in that population, what I want is a mixed bag that's approximately the same percentages, but on a smaller scale. So I would find an equal number. Like if I want to know something about the entire high school, I'm going to ask an equal number of freshmen, juniors, seniors, the same ratio of boys and girls, right? Those types of things. Okay, and then we could even go into nationalities and backgrounds and those types of things to try to get a well-rounded picture of what the entire population would be like. And if I've done a good job, my sample should represent the entire population. Does that make sense? Okay, I'm going to talk really fast through here, and hopefully that'll do something here in a second. No? Okay. We'll come over here and we'll do it manually. Sampling, that's different than a sample. Okay, sampling and a sample are two different things. Sample is this group of people. Sampling is the process by which I get this group of people. The process of choosing the same to be examined. A representative sample will have the same characteristics as the population, but on a smaller scale, as I've just described. Probability sampling. Every individual in the population has a known probability of being selected, and this probability is greater than 0. Which means if I want to know something about the entire high school, then everybody in the high school has a certain probability of being selected. Okay? It's a known probability. Okay? If you're in here and you're a girl, there is a specific probability by which I might pick you to answer a question, right? How many kids are in this class? There's 18 students in the class, 17 today, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 girls in here. 11 out of 17, right? That's the probability, right? Number of desired over number total. That's a probability. In fact, if you're in here and you're a girl, you have a higher than likely chance of being picked to select a question, correct? Right? If I'm only selecting girls, or a girl has a higher probability of being selected. If you're in here and you're a boy, you have a relatively low probability of being selected because there's only, 6? Right? Something like that. All right. But if I said, hey, I'm going to pick somebody to answer a question who's over 7 foot tall, none of you have a chance. Okay? Simple random sample. Now at this point, I'm taking information that's in your book, that's in charts. I believe this information you'll find in a chart on page 522. I've taken that chart and I've tried to break it into separate slides here so that you can look at it. Simple random sample, otherwise known as SRS. SRS is how they break this down. Okay, so if you see something referring to SRS, they're talking about simple random sample. That means every member of the population has an equal chance of being chosen. Okay, so if you're in the high school, you have an equal chance of being chosen. It's random. Example, the names of all students in a class are put into a hat. 5 names are chosen at random. Everybody's included in the group. Okay? Now, if we said, hey, you have a certain GPA to have your name put into the hat, or it's people with a certain number of AR points, or you have to do these certain tasks, now it's filtering out, right? That's not a simple random sample. Okay? Because it's not the names of all students. It's going to be the names of the students that fit that particular group. Stratified sample. The population is divided into mutually exclusive groups, which have similar characteristics, and a simple random sample group is done on each group. So if I want to know something about the entire high school, I could take my freshmen, my sophomores, my juniors, my seniors, break them up separately, right? Instead of picking instead of throwing all 4 classes into a pool and pulling kids from that randomly, okay, stratified sample would have me break that into 4 categories and then do a simple random sample from each of those 4 and put that into a separate bucket. Does that make sense? Okay, the class is divided into boys and girls. 3 names are chosen at random from those particular groups. Okay? So if I did that in here, right, your name as a girl would have a smaller probability of being chosen. Your name as a boy would have a high probability of being chosen because you would be going from 1 out of 11, and the boys would be coming 1 out of 6, right? And if I'm picking 3 boys and 3 girls, right, I only have 6 guys. So if you're a guy in here, you have a 50-50 chance of being chosen. If you're a girl in here, you have like a less than 10% chance of being chosen. Well, higher than 10%, but. Okay, systematic sample. A member of the group is chosen at a regular interval. Okay, systematic. Every so often we pick another person. Okay, the names are listed at random and every 8th name is selected. Okay, systematically. Cluster sampling. The population is divided into groups called clusters, and the clusters are randomly chosen. This would be where, let's say I took, again, freshmen, sophomore, junior, seniors. All right, I divided them into separate clusters, and then I just pick a cluster. And I take that entire cluster. So juniors win, right? And the juniors are going to get a pizza party this month, right? That's a cluster sample. Survey may be given to a randomly selected homeroom. So your homerooms are clusters, and then we take the whole homeroom and do something there. Okay? Are we understanding these as I'm explaining them further? Hopefully. Okay? Convenience sampling. The surveyor simply selects whoever is convenient for them to select. This is not probability sampling because people in the population who are not convenient to the surveyor have no chance of being chosen. What I want you to think about here is, you ever watch like a late night show like Jimmy Kimmel or Jimmy Fallon or somewhere like that where they have the man on the street, right? Have you ever seen the man on the street asking random people that happen to walk by? All right, do you have any chance of being asked a question by the man on the street on Hollywood Boulevard? No. The only way in which you would have a chance is if you happen to be on that street when the surveyor is out there. Until then, listen, you're never going to get asked so long as you are not where the surveyor is. Okay, when the surveyor is asking a question. Selecting individuals who happen to walk by on the street. Okay? So it's whoever's closest to me. Okay, if I'm the one surveying. Okay, voluntary response. Voluntary response is a lot like, during elections or something like that, or you get your parents probably. Do your parents ever complain about getting called, especially during election season, to answer a survey? Yeah. Okay. So that's a voluntary response. What do I do most of the time? I hang up, right? But there are some people that volunteer to answer the survey. Right? That's a voluntary response. The individuals in a sample choose themselves. Or it could be something like Publishers Clearinghouse, where these Publishers Clearinghouse things get sent to everybody, but it's the only people who turn them back in are the people that are in the pool to be chosen. Okay? The population may receive a questionnaire in the mail. The sample consists of only those who choose to return it. Note that controversial questions tend to be answered mostly by those who have very strong opinions about that issue. For instance, there's going to be a vote here before very long that I think is going to deal with the new school, right, and the tax and all that kinds of things. If they put out a questionnaire to everybody in Sullivan County or whatever it would be chosen to be taxed, the people who are likely to answer the questionnaire are people that are extremely for it or people who are extremely against it. If you're on the fence, you're probably not going to take the time to answer the surveyor. Right, if you really don't care. Okay, so you don't get a whole lot of fourth graders that care about taxes, so fourth graders don't typically answer a whole lot of tax-related surveys. But what comes into this is something called bias. Bias, a sampling method that favors certain outcomes. If I ask a question a certain way, it's going to favor a certain outcome. The sample is then not representative of the population, and the results of surveying the individuals in the sample do not truly reflect that of the population. I'm a guy, and so if I wanted a survey to say what I wanted it to say, and my survey was about, let's say, making paintball a school sport, right? But I only asked other boys what they thought about it. Okay? Would my sample represent the population? No, and so I went at it to get a certain result. Well, I interviewed or I surveyed 150 people. That's a lot of people, and I got like a 98% of people say that they would be on the paintball team, right? But if I had surveyed a bunch of girls, now granted, girls really do surprise me because I played a lot of paintball, and it tends to be that the girls are actually more vicious paintballers than the boys are. I might actually get, more luck with the girls. How many of you girls would play paintball if we had a paintball team? Yeah, I see. Big chunk of you. Okay. So, but in any case, bias can result not only from poor sampling, but from poorly worded questions as well. Questions that are confusing or leading the reader towards a certain side are biased. Let's say for a second that we go back to the paintball question, but I don't want a paintball team, right? And so I'm going to say, how many of you really like getting bruised? How many of you like eating paint? How many of you like, and go over all the most terrible things that involve paintball, and then say, how many of you would like that? What am I trying to do? I'm trying to drive the numbers down by painting paintball in a negative light. Does that make sense? So I am creating bias within the survey, okay, by asking questions or asking leading questions. Or you can even make the question confusing. Now, this is the only math portion of this lesson, and it's called the capture-recapture method, and we use it to find the estimate of a certain population it's hard to necessarily know. Okay? Typically, this is done by, let's say, conservation agents to find out, how many rabbits live, or how many foxes, or something like that live within a certain area. And what they do is they do this on two different attempts. They go out and they catch a bunch of foxes, and they tag all of the foxes that they caught, all of them. Okay? Then they go out a second time, right? And they catch a bunch of foxes. Now, is there a chance that some of the foxes that they caught the second time are already tagged from the first time? Sure. And so what we see is we have a number of animals marked, okay? And we have number of animals marked on the second visit, number of animals captured on the second visit. This is number of animals marked. This should say, first visit. Okay? And what we are solving for is this. So all this is a proportion. Okay, so if I know how many we caught and marked the first time, and I know how many we marked the second time, and I know how many we captured the second time, then that should give me an approximate number for how many foxes live in a certain area or population. Okay? That's the biggest math portion of this. It's just a proportion, but you do need to know how that's written up and where you're going to put those numbers. Top left, top right, bottom right. Okay? And I believe that is it for that. Let's try to answer at least a handful of questions here. Thank you guys for listening closely. All right, so this is question number 1 is actually going to include the whole capture-recapture thing. So did we write that up? Okay? So we're going to create a proportion. So the very first thing I want to do is I want to get my proportion ready. A researcher visits a wildlife refuge and captures and tags 31 rabbits. Where does that information go? Top right. Great. 31. Okay? The next day, the researcher captures 35 rabbits. 9 of them are tagged from the previous day. Okay? Where does 35 go? Bottom left. Okay? Okay? 9 of them are tagged from the previous day. So where does that 9 go? top left, and we're solving for this. So you guys have calculators. I want you guys to solve this and get your answer back to me. 35 times 31 divided by 9. Let me see if I should have my paperwork here. Maybe I don't. What is this? Lesson 73? I thought I had it. Do we have a number? 120. Is that what? So 120.5. But here's the question: can we have half of a rabbit floating around out there? You could, but it's going to be a freaky thing. You're going to wonder what happened, right? All right, so we should get 121 rabbits. Let's check that. A is my answer. All right, so we did everything right there. Okay, what time do we get out of here? You guys already know? Right now? Okay. All right. We will stop there. We will finish up this lesson tomorrow. Okay, so I can walk through this stuff with you, make sure we get it, understand it. So tomorrow's a work day. Okay, but chances are I will finish this video in the other class, so you'll get in class time tomorrow to work through it. Okay.